So we start with the Kirchoff's rule. So the first rule is the junction rule. It basically says that at any junction, the sum of currents entering the junction is equal to the currents leaving the junction. So for example, here the currents entering are I1, I2 and I3. So this is equal to I4 plus I5. Similarly here, the current entering is I1. So I1 is equal to the current leaving the junction. The sum of currents leaving the junction is I2 plus I3 plus I4. The second Kirchoff rule is the loop rule. That is, the sum of changes in potential around a closed loop is 0. So very first example is delta V minus IR is equal to 0. So this you can see right here. So delta V is the potential of the battery, and you first fix a direction. So direction is going from the positive side of the battery outwards. So this is the standard direction we fix. So you have delta V minus IR is equal to 0. Then you put another resistance in line, then the battery potential remains the same. So now the loop rule says delta V minus IR, then minus I times small r is equal to 0. So again we give a direction to the current. The direction is like this. So this is basically saying you're coming out from the positive side. Now suppose you have two batteries and their similar sides face each other, that is negative faces negative. It could be positive facing positive, the result would remain the same. In this case you again fix the direction like this, current coming out of positive. So first you have delta V1, then you encounter resistance R, so you get minus IR, and then you get minus delta V2. You get minus delta V2 because current I is entering inside it, not leaving it. So our orientation is as such. So we put this circle like this. So this circle has to come out of the battery for battery to be positive. But you see the arrow, it is going inside the battery. So this is negative. Now you have two batteries which are placed in proper order, that is serially. You have positive, negative. With the negative side you have put a positive side and a negative side. Now if you have orientation like this, then the current comes out from here, out from the positive side and in from the negative side. So delta V2 would be positively entering the equation. So you have delta V1 first, then you drop potential by IR once you pass this resistance. So you have minus IR, and then you add delta V2 to it. So these equations are very important and you need to remember them. Now we cover two more circuits. So these look slightly complicated, but in these circuits we will use both junction rule as well as the loop rule. So let us focus on the first circuit. So in this circuit, let us label this the A, B, C, D. So say this is delta V1 and this is delta V2. So this is resistance, say R1, this is resistance R2, this is resistance R3. So first focus on the loop A, B, C. So here we want to come out from the positive side of the battery. So let us make the loop like this. That is, you go from A to C, C to B, and then B to A. Now when you're going from A to C, we have to then keep on dropping the potential. But first use the junction rule to allocate the current. So minus I1 is coming out from here. In this junction, minus I1 is going in. So say I2 goes here, then you will have I1 minus I2 going in here. So you still have I1 minus I2 here. We are using the junction rule. So at this junction you have I1 minus I2 coming in here, you have I2 coming in here, add them up, you again have I1 coming here. So you have the junction rule is satisfied. So let us now focus on this triangle ACBA. So from A to C you have resistance R1, current is I1, and this we also have this delta V1. So you will have delta V1 minus I1 R1. Then you are at the line CB. CB again you have, it is going in, the current is going in the direction of CB. So you again have nothing much to do here. Put the negative sign. You have minus I2 R2, and you are back at junction B. No resistance is here between B and the battery, so you just put this equal to 0. Now we focus on this side. So we focus orientation like this, that is you coming out from positive side. So first thing is that now we are focusing on the triangle. So we are going from battery to B to C to D. So we have B, C, D, B. Now we want to go from B to C. So that is the way I've drawn the arrow. B to C, C to D, and then D to B. So B to C. Now the current is flowing in the opposite direction. We are trying to go from the positive side from the battery, but now the current I2 is in the opposite direction. So since current I2 is in the opposite direction, first just let us write down the battery. The current is in the opposite direction, so instead of negative sign, we will now put a plus sign. So you will have I2 R2. And I1 minus I2, this is fine. This is in the same direction as we have taken the orientation. That is, we are going from C to D. The current is also going from C to D. So you again put a negative sign here. I1 minus I2 R3 is equal to 0. Similarly, we will have same thing here. So first of all, we label the triangle. So you have delta V1 here, say delta V2 here, and we have resistance R1, R2, R3. So first we will use junction rule to allocate the current. The current is coming out from the positive side of the battery. Say we have I1. So I1 is coming in here in this junction. Now say I2 goes here, then the current coming in here will be I1 minus I2. So current coming back here would be I1 minus I2, and you add I2 back to it, you get I1. So first worry about this this loop. So let us give it orientation like this. You start with delta V1 minus, so I1 is in the same direction as this loop. You get minus I1 R1, then again I2 is in the same direction as this loop I have drawn going up. So you have minus I2 R2 is 0. Now here I will draw the loop in the opposite direction. So this is the direction of my loop. So basically that means the direction of the loop. I'm just drawing the direction of the loop. This way, loop is going this way. Okay, so that is this is what it shows us, that how we should proceed. So delta V2 we write as it is. Then the current we encounter in this passing through R3 is I1 minus I2. But I1 minus I2, as you see, this will be going like this. This is in opposite direction to our loop. So this is opposite to our loop. So we have to put a positive sign in front of it. So plus I1 minus I2 times R3. So we are going from here. So this resistance is done. Now we focus on R2. Now on R2 you see that loop and the I2 are in the same direction. So we don't have to worry. So you just have minus I2 R2 equal to 0. So notice that the equations depend upon how you assign the loop. So this takes some time to practice with how you assign the loop, but either you can assign the loop, just put a small circle like this with the arrow, or just put arrows all along the border. So for example, in this first diagram, we had the loop went like this direction, and this direction for the 3 arrows. So everything was negative, was fine. R1 was fine, R2 was fine. In the second part, our loop went like this direction, and this direction. So this direction was fine with the current, but this direction was opposite, and that is why you had a plus sign.